All right, looks like we're off and ready to go. Welcome back here, right? This is the second little mini lecture in the series of the body system, just to try to get you used to being sort of back in the classroom and maybe just, hearing things from an actual person instead of doing those style modules. So this is sort of how we're doing it now. What we're going to do is get started onto the digestive system. Now, the digestive system is the first thing that style covers, and I'm going to be doing this a lot like how style tends to structure it. But what we're going to do today is sort of have a look at this, and this is sort of just meant to be a brief overview of everything. You'll of course watch this, then go on to style and do the module. So let's get started. There we go. Sorry, I'll get that out of the way. Look, so our learning intentions for this particular lesson, by the end of this, we want to be able to describe the role of the digestive system in maintaining maintaining a human as a functioning multicellular organism. Also, we want to understand how nutrients enter our body and how they are broken down and absorbed for our use. So what is the digestive system? So the digestive system is a collection of organs responsible for the breakdown and absorbance of nutrients from food. Sorry, I keep on saying absorbance wrong. So that's basically what it is. It's there to absorb absorb nutrients from our food. That's the big takeaway here. So what does it look like at a glance? So hopefully you can see my mouse again. This is what it looks like at a glance. We have this obviously we have our mouth, and we have this long pipe that goes down from our mouth, and then we have this collection of organs. Now we're going to go through what each of these organs are and what they do. So hopefully we can sort of trace what it looks like when we take in some food. We're going to trace down and go all the way down into our stomach, into our small intestine, into our large intestine, and we're just going to look at how this actually works. So let's get started with the mouth. We eat a piece of food, it goes into our mouth. So what is the mouth? It's what we eat with, obviously. It's responsible for breaking down food or breaking food down. Two ways of doing it. It does it through chewing and it does it through enzymes. So when you chew, you're doing a thing called mechanically digesting something, and all that means is that you're breaking it down. You're sort of crunching it down into little pieces, so it's easier to absorb. The second thing is enzymes. Now, enzymes, I feel like, they're in your mouth, so you know what they feel like. But what it does, if you can right now, go get a cracker or a biscuit from the cupboard, put it in your mouth, and just let it sit there for a bit, and notice what happens to it. Because don't even chew it at all, just let it sit there with your saliva. What you'll find is that it starts to break down. So don't even chew. Try that out. Pause the video here, go grab a cracker or a biscuit, put it in your mouth, and just see what happens when you let saliva do its thing. That's the first thing it does. It's to make sure that our food goes from this really big piece to a really small piece. Where does it go from there? It goes to the esophagus. So it travels down the esophagus, not the trachea/windpipe, to the stomach. And this is kind of what it looks like. We start out here, we swallow a bit of food. So let's just say it kind of looks like a chicken nugget. So we've got this green chicken nugget, and it goes down. And this forceful action is what it looks like. See, it sort of starts out really wide here, and then there's this muscle that's pushing this particular chicken nugget through. And it pushes this chicken nugget with the muscles all the way through into the stomach. Now the lining of this esophagus is kind of like mucousy. It's so that it can just slide through as best as it possibly can. All right, let's go to the next one. The stomach. Now, you probably know a little bit about the stomach already. You've probably heard that it's quite acidic, and it's very acidic. It has a pH of about 2. It's very, very strong, very acidic. If you've ever vomited before and you feel that weird sort of sensation in your mouth, that's from all that acid just sort of being there and being present in your mouth. So it's there to break the food down a little bit further, but it's also there to kill off bacteria. So it makes it a bit of a inhospitable environment for bacteria, which is really good because we don't really want bacteria coming in with our food. If you think about something like salmonella, we don't want that in our food if we could possibly get away with it. So having that really acidic environment helps to do that as well. The second part there is that it contains enzymes to break down food. That's meant to say break. So break down food as well. Just like how the saliva breaks down that cracker in your mouth, the enzymes here break down the food as well. And the last thing it does is it squishes itself together to move move the food around. So it squishes itself together. So if you can imagine, this thing's like contracting all the time. It's sort of like, if you would imagine you have a balloon in your hand and you start squeezing it with your hands. Imagine like that. Imagine there's food in there. That's what it's doing. It is moving that food around so it gets lots of acid and enzymes over it so it can break down. Where does it go from there? So we have the esophagus here. It's gone from the esophagus to the stomach. The stomach's done its thing. It's put some acid on it, it's put some enzymes on it, and then it sends it to the small intestine. So the small intestine is the next part. So we're going to have a look at this. So the small intestine. Now the small intestine is where most of the absorption takes place. This is where most of the absorption of nutrients, such as carbohydrates, fats, and proteins, takes place. And they do it through these little finger-like things called microvilli. So these are the microvilli here. So if you could imagine, imagine this is your skin, right? Imagine if your skin had all of these tiny little projections, like hair, I guess, coming off it. That's what the inside of your small intestine looks like. And what happens is all of that, everything that happens here, comes into this particular section and it glides through these microvilli, and microvilli sort of act like a mop. So if you can imagine trying to mop something and you didn't have these little absorbance pads, then your mop probably wouldn't work very well. It's there to do a thing called increase the surface area. So if we can increase the surface area, we can make sure that we can absorb as much as we possibly can. And I have an example at the end there about what happens when this isn't the case. And it's actually something that's quite specific to myself because I have a disease that can affect these microvilli, but I'll get to that. So small intestine, this is where most of the absorption takes place. The next one is the large intestine and the anus. So let's just recap what's happened so far. We've gone through the mouth, we've been digested. Well, let's just say we're a piece of food. We've gone through the mouth, we've been broken down, we go down the esophagus, we go into the stomach where we've been treated with acid and enzymes to break us down even more. We've gone into the small intestine where we've started to be absorbed by the small intestine's microvilli. And then the last one, or basically the last step here, is that we go through the large intestine and then out through the anus. So this is in the small intestine, this is where leftover water is reabsorbed back into the body, and it leaves behind feces or poo. So this is largely where poo is formed. All that water that was in with all of those, I suppose it would be like a slush of nutrients and acid and enzymes and that. This is where all that water gets reabsorbed. So we want to keep as much water in our body as we possibly can. So we've sort of tracked it how it goes. I think you guys know the process of getting rid of feces from the body. I don't have to explain that. But yeah, so this is basically what happens. Now, there's 3 other big players in this particular part that you might have noticed at the start. We have the liver, which is this guy right here, kind of sits near the stomach. We have the pancreas, which is also kind of near the stomach. And then we have the gallbladder, which is also kind of near the stomach. Go figure. So these big players, the liver gets rid of toxins. So there's a bunch of toxins that you might ingest. Some things are less toxic than others, but the liver's main job is to get rid of those toxins before they can get into your system and cause a rug. The gallbladder produces bile to break down fats from food. So those enzymes we were talking about, those enzymes are really good at breaking down things like carbohydrates, but they're not so good at breaking down things like fat. So that's why we need the gallbladder to produce this bile to break down the fat. The last thing is the pancreas. Now the pancreas, which is this little thing here, produces enzymes as well for breakdown. And it also produces two hormones called insulin and glucagon. Now, if you know someone with diabetes, diabetes has to do with the dysregulation, or like it has to do with this particular hormone. Oh, there it is. This particular hormone, insulin, being mismanaged. If we can't create enough of it, or we can't create enough any of it at all, then we can have issues with absorbing our food later in the process. But don't focus that on too much. We've talked about the big players. These are the smaller, these are the lower players. But it's also, I feel like the most important one here is the liver. Understanding that the liver gets rid of toxins. So what are the main components of food? Now, I talked about this a little bit before. The main components of food are carbohydrates, fats, and proteins. They're the main parts. If you look at a nutritional label, you'll be able to see those on there, and I'll actually show you one in a second. You also get things called micronutrients from food. They're smaller in portion, but they're really important. So instead of being in grams, you know how we have kilograms? Instead of being in grams, they're in a thing called micrograms, which is a factor of about 100 or so, or 1,000 technically. So they're actually quite small. Imagine like half a gram of something being a lot of micronutrients. So these are the things like vitamin C, B12, iron, calcium, and potassium. These are just examples. They're micronutrients, very important. All right, so this is a nutritional label. Now, when I was talking about the proteins, fats, and carbohydrates, this is what I was talking about. When you get any sort of food product from the store, you will get a nutritional label, and the nutritional label will have the proteins, it'll have the fats in grams, and it'll have the carbohydrates. It'll also have the energy that we extract from it in kilojoules. It has the amount of fiber potentially in there, and it also has, sometimes it can tell you what micronutrients in there, but in this case it's telling us how much sodium is in there. So sodium as in like sodium chloride salt. A very important nutrient, but one that you don't want too much of. By the looks of it, this looks like a particular cereal brand. So it's got a bit of wheat, oat bran, barley. It's got some psyllium husk for fiber. It's got sugar, it's got rice, it's got malt extract, honey. Yeah, I'd say this comes from a cereal. And it's actually got quite a bit of sugar in it. Hasn't got a lot of additional sugar, but it's got it's got a lot of carbohydrates in it. Now, those carbohydrates, they'll give you that perk in the morning, especially if you're having that cereal, I guess. So yeah. All right, we'll move on to the next one. Why do we need these things? So we need these things to provide us with energy, and they also help to provide us the opportunity to do different processes in our body to make sure that we're able to grow and maintain and repair ourselves. For example, someone with an iron deficiency can go through the day and be very sleepy, very pale, and they might be really sluggish. So if you feel like you're very fatigued a lot of the time, it's possible, and it tends to be more common in girls than boys, that iron deficiencies become a thing. So iron deficiencies are really important to get checked out, and it's something that you should be aware of. But there's plenty of other deficiencies, like vegetarians, for example, and vegans, they can tend to have a vitamin B12 deficiency. People that don't live in a sunny climate can suffer from a vitamin D deficiency. So these things are really important. Now, the disease I was talking about before to do with digestion, it's called celiac disease, or the one I'm going to talk about is called celiac disease. Now, there's a protein called gluten, and you'll find that protein in things like bread and cakes and pies and all that delicious stuff that you love. But I can't eat it because I have celiac disease. My body looks at that gluten and it says, nope, don't want that in my stomach. Don't want that anywhere near me. Get it away. I don't want to absorb that. It's a foreign invader. I hate it. Get it away from me. So if we have a look at the difference here, these are those microvilli, and they kind of look like that part of the mop that I was talking about. So if you have a look at that, we've got these nice big gaps where that slush can go through. But in this one, We've got none. They've completely disappeared. Now, I heard a interesting fact one time. When someone with celiac disease eats gluten and they go in this particular scenario, they have the surface area in their small intestine. It goes from being the size of a tennis court. So imagine if you chucked a bucket of slush on a tennis court, how much that would do, versus chucking a bucket of slush onto a table tennis court, so one of the small ping pong tables. That's the amount of difference it makes for those people. It means that we can't get a lot of nutrients, and it can actually lead to a lot of those deficiencies that I was talking about before, like B12 and iron in particular. If you have low iron, you might have celiac disease, and it tends to be a very, very common underlying symptom of celiac disease, but something to keep in mind at least. Finishing up, I feel like we've gone through everything. You can feel free to go back. If you feel like you've missed something, you can go back and take notes. I'll be putting this PowerPoint up into the Google Classroom as well. There's a TED Ed talk there to go through, and it's a bit more well, not interactive, but more animated than what I'm doing right now, and it'll sort of go through how your digestive system works. There's also a Scootle activity there where you can actually click on that and it'll take you to an activity to do on your computer that'll show you how the digestive system works. And then the last thing we want you to do is to complete the style module on the digestive system. Okay, that's basically it for today. I want to wrap it up there. It's about 17 minutes like the last one. Hopefully it wasn't too long. Hopefully I didn't speak too quickly. Hopefully you got a bit out of it. Let me know. I'm going to post another Jamboard. Let me know on that little ticket how you felt this went so I can make adjustments in the future, okay? Sorry about the one spelling mistake. I'm trying my hardest to get rid of them, but yeah. All right, I'll leave it there. Thanks for watching. I really do appreciate it. Bye.